Kia ora. Let's look at some tips to remember the functional groups that you need to know for NCEA Level 3 Organic Chemistry. So the first group of molecules are the hydrocarbons, which I think is fairly obvious, contains only hydrogen and carbon. And there are the three different types of functional groups: alkane, alkene, alkyne. And a way to remember them is think of the alphabetical order, A, E, Y. A at the top of the alphabet has only carbon-carbon single bonds. Y at the bottom of the alphabet has carbon-carbon triple bonds. And E in the middle, or more or less in the middle, has the carbon-carbon double bonds. If I replace one of those hydrogens with a halogen, so that's a group 17 element fluorine, chlorine, bromine, iodine, then I have a haloalkane. If I replace it with an OH, think of alcohol, the OH. So the alcohol functional group is an OH bonded to a carbon, and it follows a naming pattern of alkanol. So alcohol, if I have something like ethanol, it ends in ol, so it is an OH functional group. If I replace the hydrogen with a nitrogen, now the nitrogen can be bonded to hydrogens or to other carbons, then we call it an amine. And think of Ni for nitrogen, and that means I have a nitrogen bonded to a carbon. And it follows a naming pattern of alkanamine, so ethanamine, for instance. Amides are similar to amines, so it can be confusing, but think of the D for double bond, because here the nitrogen is bonded to a carbon that's singly bonded, whereas here the nitrogen is bonded to a carbon that is part of a carbonyl group, where carbon is double bonded to an oxygen. So the D for double bond, and it follows the naming pattern of alkanamide, so this would be ethanamide. Now, amides are actually derivatives of carboxylic acids, which you may have come across before when you've reacted vinegar with baking soda and so on. And it's the COOH functional group. So if we wanted to recognize it in terms of the name, it goes alkanoic acid, the ic acid. So for instance, vinegar is actually ethanoic acid. So it has a COOH functional group in it. If I replace the OH with a chlorine, it becomes an acyl chloride, and it follows the naming convention of alkanoyl chloride. Think of the "-il" in the end and the chloride to help you recognize this functional group. So if I had ethanoyl chloride, it means I have a carbonyl from the "-il" and then the chloride. The ester is the trickiest because it doesn't seem to have any connection with the functional group, but it may be helpful to remember that it's in two parts. So it's a C double bond O, which is also bonded to a carbon, so not to a hydrogen as up there. And if you remember that the single bonded oxygen comes from the alcohol part, which combines with the carboxylic acid part, which has the carbonyl carbon in it. So whenever you see this sort of linkage, try and break it down over there and think this part all comes from the alcohol, this part all comes from the carboxylic acid. So when I name it, the alcohol part is the alkyl part, so methyl, and the alkanoate comes from the acid part, which would be this bit over here, ethanoate. The final two are not derivatives of carboxylic acids, even though they do contain the carbonyl carbon. We have the ketone, the O for the oxygen to help you remember, and the K for because it's surrounded by carbons. Bit silly, but it may help you remember. Compare this to the aldehyde. The aldehyde, the H for hide, means the hydrogen is attached directly to that carbonyl carbon. And the naming conventions, it's alkanone, so the one for ketone. So this, for instance, propanone, whereas in aldehyde, it ends in L. So for instance, this would be ethanol. So I hope this has been useful to help you remember the functional groups and their naming conventions. Goodbye. Kia ora.